Hey, kiddos, it's Wednesday, and today we're going to start our unit on energy and motion. I told some of the kids at school yesterday, this is probably my favorite unit. Not that I don't like them all, but I like the topics in this unit. All right, by the time we get done with this lesson, which will probably be right before Christmas, you're going to be able to, down here, describe how energy is conserved, meaning, remember, it's not created or destroyed, it just changes its form. It transforms in between one form to another. We're going to, first of all, today look at going from potential to kinetic. And there's just one simple objective this time for this lesson. You can compare, tell facts about potential energy and that about kinetic. And you can classify something. Is it potential? Is it kinetic or mechanical, which will be a term you will learn. And then a few days from now, we will look at different forms of energy and examples of those. All right, just one standard for this lesson, two kinds of energy, kinetic and potential. All right, today on the Engage Your Brain, these are 4 questions and you're going to see them in our activity. My hair, geez. You're going to see them in my activity or your activity, your assignment later. So pay special attention to these 4 questions. First one, energy can change from one form to another. Sorry, guys. We just talked about that in the standard. That is the whole point of the lesson, is that energy can change from one form to another. So true. Can it only have one type of energy at a time? So can it be only gravitational potential and nothing else? Well, no, that is false. It can be a couple types more than that of energy at a time. If an object has energy, it must be moving. So if you say something has energy, it has to be moving. Nope, that is false. And all energy travels in waves. Remember, like sound waves? Well, that is actually false. Yes, there are sound waves, but energy travels in different ways. So real quickly, let's look here. Write a caption or a description of the picture that includes sound energy. They just suggested that the sound from the marching band is caused by vibration of air particles. Remember way back to our sound lesson, we talked about vibrations. Okay, law of conservation of energy, and we will talk a lot about that, not in today's presentation, but probably either Friday or next week, okay? Energy is conserved, okay? It isn't created or destroyed, okay? So that's where the word conservation is. So if you look at the example sentence, according to the law of conservation of energy, when a rolling ball slows down, the energy of the ball does not disappear. Instead, it changes to energy as heat. So the energy of the ball has changed to heat energy. So to describe or to define the law of conservation of energy, it is a law that states that energy can change forms, but it is not created or destroyed. All right, first major important definition. It is a question on your assignment today. The definition of energy. It is the ability to cause change. All right. And as I said, tomorrow you will see, or Friday, one of the days, you'll see all the different types of energy. There's many, many forms. But the 2 main general categories are kinetic and potential. All right, kinetic energy is the energy of an object that is due to its motion. I feel like maybe you had some of this in the 5th grade. Mrs. Davis might have started it right before the pandemic. But if you did, good. If not, you'll catch right on. All right, all moving objects have kinetic energy, but the amount of the kinetic energy depends on the object's speed and its mass. We will look at things called Newton's laws of motion in the next few weeks, and they're very dependent on the mass and the speed. All right, So kinetic energy always increases if the mass increases. So as the mass goes up of whatever it is, you need to know that the kinetic energy will go up. All right, so let's look at this question. Again, you're going to have it later today when you get to the questions. Which object has greater kinetic energy if they're moving at the same speed? So if the semi is moving at 50 miles an hour and so is the little red car, which one is going to have more kinetic energy? Well, if they're moving at the same speed, it goes to their mass. So obviously the truck would be bigger, so the yellow truck, because it has more mass. All right. Kinetic energy can also increase as speed increases, which kind of makes sense. So if you have two things with the same mass, so let's say these two bowling balls have the exact same mass, which one would have more kinetic energy? One that's moving at 10 mph as miles per hour or 15, okay? So as the speed goes up, so is the kinetic energy. So the 15 mile an hour bowling ball would have more energy. Okay, now kind of the opposite, I guess you'd say, of kinetic is potential, all right? And it is based on the object's position, like think of on the top of a hill, a skier, a roller coaster, any of those type things. Condition or chemical composition. Chemical composition deals with, well, lots of things, but food being one. All right, so if it's based off an object's position, that's called gravitational potential energy. Think of gravity pulling something down, okay? So if the height goes up, so as you go up of a roller coaster, okay, the potential energy is going to go up. Also goes up if mass increases, just like in kinetic. All right. Then there's another type called elastic. If you think of stretching a rubber band out, okay, that would be elastic potential energy. All right, so here's a couple pictures of gravitational potential. Looks like Cedar Point, okay, and we're going to look at a video in a second. But that would be the height of the gravitational potential at the top of the hill. Now here it started to go down a little bit. All right, sit back and enjoy and think of summer at Cedar Point as you watch this quick little video, but that will indicate gravitational potential. Then as it goes down, it's going to transform or change into what? Kinetic, yeah. And then as it goes back up, the kinetic will go down while the potential goes up. And down we go. Okay, there's a lot of kinetic energy right now. Now we're changing to potential. And now we're going back to kinetic. And the ride is over. All right, so that's the greatest example. Okay, there would be elastic potential energy the further you bring the rubber band back. Also, of course, a bow and arrow. Okay, that's all depending on elasticity. All right, The next one is the chemical composition. Composition, remember, means the makeup. So the chemical makeup. All right. So as bonds break and new bonds form during a chemical change, we're going back to those chemical changes again. Okay. Energy is released. That's one of the major signs of a chemical change. Of course, food. Okay. As you eat the food, okay, that turns into potential energy in your body. All right. And yes, an object can have both kinetic and potential. Okay. Again, moving objects convert or change potential energy to kinetic as they move. So as we go up the roller coaster track, the very top, it's the maximum amount of potential. And then as we go down, it changes. All right. So here we're at the beach and we're at a skateboard park type thing. And I know you guys can read, but I want to share this with you. As the skater moves up the ramp, he gains height, but he loses speed. So his kinetic energy is converted or changed back to potential. Okay. Then there's one other portion or piece that is turned into heat because of friction. And we'll get into friction in a little bit. Okay. So then the skater, if you can visualize, goes up, then they come back down. At the bottom, the kinetic energy is at its peak or the fastest, okay? And the potential energy is at the lowest, okay? So now, let me move me, okay? So here at the top, the skater has potential because of the gravity is going to pull him down. This would be gravitational potential, not moving, so no kinetic energy. As he moves closer, the potential is going down as much as the kinetic's going up. And we will look at that, especially during the digital lesson, but they move exactly the same. As potential goes down, kinetic goes up. All right, and one last question. Do you think the skater has any gravitational energy at point C? Point C isn't even on here, but we will look at the answer. No, he's at the bottom of the ramp. Gravity cannot pull him any further, so he has no gravitational potential. And we'll look at something about that later. All right, that is it for today. I'm sorry, I know it was long, but take care. Get stuff done today. Have a good day. Stay safe. Mask up.